Hello, my name is Rony Fernandez. I will be solving problem 16.2 in the chapter for chemical equilibrium. Let's get started. So the problem reads, if Kc is equal to 0.042 for the reaction of phosphorus trichloride gas with chlorine gas to create phosphorus pentachloride at exactly 500 Kelvin, what is the value of Kp for this reaction? I want to start off by writing down what we are given in the problem. We know that Kc, or the equilibrium constant for concentrations of solution, is equal to 0.042 for this reaction. We also know that K is unitless. We are also told that the temperature is exactly 500 Kelvin. Lastly, we are trying to solve for Kp, the equilibrium constant for partial pressures of gases. For our next step, we are going to make sure that the equation is balanced. So we are going to do phosphorus tetrachloride gas and chlorine gas, which we know is Cl2 since chlorine is a diatomic molecule, react together to produce 1 mole of phosphorus pentachloride gas. Since the problem gives us Kc and temperature, and we know the number of moles for the reactants and the products, we can use the equation that demonstrates the relationship between Kc and Kp. That equation is Kp is equal to Kc times R, which is the universal gas constant, times temperature raised to the power of delta N, which is equal to the moles of the products minus the moles of the reactants in the gas phase. Now that we know the equation, we are going to plug in our givens to solve for Kp. So we know that Kc is equal to 0.042. We're going to put that in parentheses, times R, which is 0.08206 liters, atmospheres, over moles times Kelvin, times the temperature that we are given, which is 500 Kelvin. And we are going to put R and T in the same parentheses in order to raise that value to the power of delta N. Lastly, we are going to calculate delta N. On the reactant side, we have 2 moles, 1 mole of phosphorus tetrachloride and 1 mole of chlorine gas. And then on the product side, we have 1 mole, which is just the 1 mole of phosphorus pentachloride. And so when we do the number of moles of the products, which is 1, minus the number of moles of the reactants, 2, delta N is going to be equal to -1. Finally, we are going to multiply everything together to get the value of Kp, which I calculated was 0.00100236, and I just dragged it out to get the most accurate number. When we look at the information we are given in the problem, we see that Kc only allows us to do 2 sig figs. So our answer for Kp is going to be equal to 1.0 times 10 to the -3rd. And we know that Kp has no units, so that is our final answer.